All right, so on this project, we're going to review setting up structure, sizing joists, sizing beams, kind of that process. So the first step I want to make sure is we have some dimensions going post to post. So we have, in this case, outside of wall to center of post, so that's fine. We have dimensions going across this way, across the posts. We have a dimension going across that one from outside of wall to center of post here. And so we want to do some going the other direction. So this is ultimately the span of that joist. So we want to do this direction as well. And then we'll do outside of wall. Wherever there's a foundation wall or a stud wall, we'll just do outside. And so we'll just do this in a few more locations here. And make sure we get the center of that beam. And then we'll get the center of this beam here. And then again, all the way out to the outside of the foundation. And then I think we need one over here. So it's a little bit trickier to find. And that really gives us kind of the start of the basis we kind of need to start sizing structure. So we've got that there. So now that we have that, we can see kind of some of our spans here. So what I like to start with is trying to find our large. Here we have the same thing. We have about 15, and then let's add another dimension here, outside to center. So 13, 10, and well, I guess we'll call it 13, 11, and 15, 11. So let's go and let's size some joists here. So we're going to open up this. This software is called IBDN. I can't remember what it stands for, but we're going to start a new project. We're going to call this our cottage project here, and then we're going to put provinces Ontario. We want to look up the climatic data. This project is in Midland, so we're going to add that there. Click Create Project. We need to add some other information. We need to add the address. We need to add project number, municipality, town. I'm not going to do that right now, but we'll need to do that as kind of a first step. Next, we're going to go into Calculator here, and this is in this software we can do a couple different things. Under joists, this is the building codes table. So it just takes the tables from the Ontario Building Code, and it allows you to. It doesn't really calculate anything, but allows you to determine if the sizes are okay. So we have SPF, we have 2x12s. So the max we can span is 15'5" on a 2x12. We can also, we're going to do bridging. We could also drop this down to 12 inches. So 16'5" is what we can do there. So if we go back to our plan here, in these areas, if we wanted to keep our 2x12s, we would actually need to change our spacing to 12-inch centers instead of 16-inch centers. And so that would be that case. This one over here would have to be 16-inch centers as well. Sorry, 12-inch centers. And then over here, this could be 16s because it's under that 15'5". Let's just see if we have any other locations that are under that. And we'd ultimately want to keep our joist sizes the same. So 2x12s here, 2x12s. Yeah, so we keep the same joist size across the whole project, even though, you know, for example, this span's a lot smaller, but we would still keep the joist size the same. So now that we have those joist sizes, we want to find our biggest beam. And again, there's a bit of efficiency potentially in using the same beam size going through. It doesn't always make sense, but we would likely keep this one. We might make this one a different size, but then keep it the same size on either side. So we have, actually this one here is 19'2". So the way basically the beam sizing works is we need to understand the whole span. So I'm going to remove this dimension after, but essentially our floor that this beam right here is carrying is 25 feet 6 inches. So I'm going to go back over here. We're going to write first floor joist. And I'm just going to write 2x12 at 16 or 12 inch. And that way, we kind of know remember what we size because we actually write it in the name. We're going to do another calculator. This time, there's a few actually options here. We can do built-up beams. These are from the building code tables as well. What we're going to find, built-up beam not supporting more than one floor. What we're going to find here is if we go to 2x12s, we go to 5-ply, our max span is 15.9. So our span and our supported length, if we take our supported length to 19, which is not even enough, we need more than that. Actually, we might not need more than that, but we're just nowhere close to that span. So let's go back to our project here. We'll go to calculator, and now we have this button here called engineered UDL or point loaded beams. And so this is essentially the way we can actually size the different beams. So this kind of gets a little bit complicated, but in here we have the different conditions. So if you have a lintel supporting just a floor, you have that. If you have a lintel supporting a floor and a roof, so you can actually add in the roof span, the floor span, all that information here to calculate that beam. Our case, we're going to do floor beam. And our floor beam, let's do 4 beam. Let's do 4 beam plus. Yeah, let's just do floor beam. So our beam span is going, in this case, left to right. So we have 19'3". I always round up. So we'll do 19'3". And ultimately this size is accounting for the wall, which we don't really need to do, but it's kind of an easier, simpler way of doing it. And it also gives us a bit more safety factor. And then our span, our floor size is this 25'6". So now we'll add, see how you can see this dimension is the whole floor, not just half. So we're going to add 25'6" in here. So it's a very big floor. So you can see we have fail, or okay. And so with all these numbers, our goal is we want to get these numbers around 50%. So 58 is probably okay, but I usually try to get them under. So now we need to change our beam sizes. So we have wood or steel. Well, let's try with wood first because contractors typically prefer wood. We're going to do LVL because LVLs are stronger. The LVLs we use in our area are typically West Fraser LVLs. And so we're going to change it to West Fraser. We'll start with a 3-ply, and we're going to change our depth. So let's change our depth to, let's say, 16 inches. And so that's pretty good. Our live load deflection is a little bit high. So maybe we'll go to a 4-ply, and let's see if we can drop this 4-ply down to 14 inches. That's a little high. So we'll do a 4-ply 16-inch beam. So now that we have that, I'm going to call this, we're going to call this BM1, we're going to call this FB, or, let's call this FB 1.1. So F stands for flush. So this will be a flush beam. So flush beam 1.1. We can also do a drop beam. I'm just going to double check the location of this beam. So this beam is over top of a wall and closet there. So that's a little bit difficult, especially when we do a 4-ply, because a 4-ply will be wider than the wall. So what I might end up doing is I might end up switching this to be a 3-ply and then going down to 18 inches. And we might make this a drop beam, so a actually let's just do BM. So BM will be a drop beam, and then FB would be a flush beam. So a flush beam would be up into the joist, drop beam would be below the joist. So we'll do BM 1.1. We can write the size here, so we'll do 3-ply 18 inches. So I'll just do 3-18-inch LVL. For LVLs, we don't specify the width because the width is by the manufacturer, which is, it's actually 11 3/4. 1 3/4, not a 2-by, which is 1.5. So I just do 3-18 inches. So let's save this. So now we're going to go back into our project here, and we're going to select this beam here, and we're going to change this to be a 3-ply LVL. So if you don't see the 3-ply LVL in here, you can load it in. It should be in the folder. But we have 3-ply 18-inch. Oh, and instead of that, 3-ply 18-inch. And the other thing we're going to do, I'm going to tag this beam before I go too far. So let's go to tag, and let's tag that beam. And I'm just going to use the tab button on the keyboard to actually find it. So right now it doesn't say our BM 1.1. So, and we're going to leave this box on because I think that box is kind of helpful to signify. We're going to turn off the leader line. But we're going to click this beam here and see how it doesn't say BM 1.1. If we go down here to our, we want to find our, where is it? We want to find our mark value. And so in our mark value, we write BM 1.1. And that should update. And if it doesn't, we just have to load our proper tag in. So let's go to Insert, Load. And we'll find our annotation tag we have. And our annotation tag is updated, so structural framing tag right there. So our structural framing tag is updated, so it has it puts the mark value as part of that. And theoretically, we could add a comment value. So if we have to do this by clicking the beam. So we can add a comment value, and the comment value just goes after the tag. So we have BM 1.1. And then if we were to add a comment value, we could write dropped. And that comment value will go after. So the mark value goes before, the comment value goes after. And so let's go to our next one. So this one looks like it's continuous right now. So let's break it. Let's break it right at that center point. So I'm just going to use the tab button. We'll break it right there. And let's grab that beam. And so this span is basically the same, it looks like. So let's call this the same size beam, 3/18 inches. And let's put BM 1.1. So because it's the same span, we can call it the same beam. It's going to give you an error saying it has duplicate mark values. That's fine. And we'll turn off leader line. And we can add a comment there as well. I think it's nice to add the dropped or flush comment just to, again, be more specific with what that beam is doing. The reason why we want to have drop beams going down the middle is because sometimes it's nice to run HVAC. So what's likely going to happen with this project is we're going to run HVAC through here. And then all of the trunks are going to go in the joist space north-south. So we'll have the ceilings kind of dropped in this corridor to run all of that HVAC. But then, let me clear this somehow. But then it would be dropped in that corridor so we can have proper HVAC. So that's why we're going to do drop beams along this kind of area here. I don't think we need this post here, but I think it might help structurally. So we might be able to actually, I think we'll probably just keep all these posts here. So let's find the biggest span. So the biggest span is 14 inches. It might honestly just make sense to keep the same beam size, but let's just look at it from a design perspective, and it might just be better to drop that. So let's go back to calculator here. Let's go to UDL. And we're going to go to let's actually find our maximum beam span. So our maximum beam span is 14'8". Our maximum joist span, let's run a dimension here. Oh, this one's actually more, it's 30 feet. So the beam span is less, but the joist span is longer. So let's go back over to here. Let's type in beam span 14'8". Joist span is 30 feet. And let's just go here and go to 3-ply 18. So that's pretty low. We could probably do a 2-ply 18. And 3-plies are a little bit nicer because they fit nicely on the beam or on the post. Let's go 14. So we probably could do a 3-ply 14. Yeah, so let's stick with a 3-ply 14. So let's go back and here. and actually we're going to call this BM 1.2 3-14 inches. And what we usually do is we will size conditions. So if we have similar conditions, we can keep that beam size the same, and we can just use the same beam number. We don't need to make all these different beam sizes. So this beam will be 3-ply 14 inches along here. So let's call this, let's change this to be a 3-ply 14. 3-ply 14. And we can call this BM 1.2. And then we can call this dropped. We can just click that there. In general, once you do this, this is kind of a nice easy button. It should keep our mark values once we split this. Let me actually delete this. I'm going to delete this column here and just see what 14.9. That's probably fine. So we can probably eliminate that column just from a. You know what? Let's leave it. Let's leave it in for now. So we're just going to split this beam at all these different posts here. And then we can go up here and tag all these. We might need to use the tab button. And then we have this beam down here. So this beam is 18'9", and total span would be, let's throw a measurement here. 20'2". So you always have to round up, even if it's over just by a little bit. You always have to round up. So let's go to 20'2". We'll call this BM 1.3, and our span is 20'2". And then this would be 18'9", I believe. I think it was. Just check that. 18'9" and 20'2". And then let's just check our material. I like to try to keep stuff similar, so let's look at what this is. So let's go to 3-ply 14. Change this to West Fraser. These are just brands, so these are just different brands in the area. We use West Fraser or truss joist typically. 3-ply 14. 3-ply 14 is actually a little bit overextended, so we maybe make this a 4-ply 14. Yeah, so let's make that a 4-ply 14. 4-14 LVL. And yeah, so let's save that. And let's change this to be a 4-ply 14. Down to LVLs, 4-ply. It is above a wall, so it actually might be better as a 3-ply. So let's actually fix that. Let's go back in and fix that. Again, if it's above a wall, we want to make it 3-ply because then it fits in the wall and they don't have to fur anything out. So let's go back to material. Let's change that to be a 3-ply. Let's change that to be 16 inches. So 3-ply 16-inch works. And let's just update our name here. 16. Yeah, oh yeah, 3-ply. Yeah, you're right. 3-ply. And then we can change this to be a 3-ply. And then we update our mark value again, BM 1.3, and then we'll call this dropped. So there's sizing a bunch of beams. Last thing I want to just show is sizing a lintel. So we have this lintel right here. This lintel is supporting these windows right here. Again, just to make things easier, I'll add a dimension from the side of the window to the side of the window. So that's a 12-foot opening. So, and then we have 11'2" as our span. So let's go back up to here. We have calculator, UDL, and I mean, we could actually try not using a UDL. We probably actually could do this one without a UDL. So let's go to calculator. Let's go to lentils, wood lentil span tables. We have spruce pine fir supporting roof and ceiling with tributary width. So this one's really just supporting floor. Well, actually, it's supporting the deck too. Forgot about the deck. So let's go back actually and let's make it a UDL just for simplicity's sake. I forgot, because there's this deck in this location here. Let me go to the call out here just so we can see that. So we have this deck is theoretically actually supporting to here, and then also back to that beam. So let's just pull this back a little bit so we can see that beam potentially. There we go. So we have around 25'10" actually that lintel is supporting. Yeah, it's in the middle. Yeah, so this lintel. Yeah, that's fine. Yeah, that's fine. It's roughly. So actually, this lintel in this case is actually a beam, not a lintel, because it's in the middle. So we're going to size it as a lintel. I'll do another one that actually is a lintel. So this one we'll do, it's 12-foot span. And usually the span is actually 12'2". So I always make the span an inch bigger on either side for lintels, because usually there's airspace on the side of the windows. So floor dimension, this would be, do you remember the number? It's 25, I think. Sorry, 25. So the span is 25'9". 25'9", and this lintel. So for lintels, I usually like to do them as a 2-ply, because then we have more insulation space. So let's go 2-ply. Let's do 2-ply 14-inch. So we're going to call this LBM, Lentil Beam 1.1, and this is going to be a 2-ply 14-inch LVL. So LBM, so L stands for Lentil Beam, and we'll go back to here, and we'll change this to be a 2-ply. Or it is 2-ply 14. And for lintels, I will always want to make sure they're aligned with the outer face of the wall. And so let's tag this. And we can go here. And we can add our mark as LBM 1.1. And we don't need to put a comment value, it's just a lintel. So let's find one that isn't there. So this one is just a normal lintel. And this one actually it doesn't have a very big span. The span's only 7 feet. So let's check this lintel here. And this what I think would be, yeah, it's around 16 foot. It's probably 16'2". So let's go, let's actually look at the lintels table for a second here. So this would be roof, ceiling, and 2 stories. Lintel size 2x12. So I mean that doesn't work. Let's just go back. Calculator, beam. You might also find just doing them in the calculator is just always easier. So let's go to lintel supporting 1 floor. So because of I guess this would be lintel supporting 1 floor. It'd be supporting 1 floor plus roof, like that. I think the joists, the rafters are going to go side to side. So I'm just going to mark the roof as 4. So that's kind of an arbitrary number. And then our roof overhang is actually really large. So I'm going to put it at 4'11". Our floor span is only 7, so it's pretty small. And our lintel span is 16'2". So this will probably be a big lintel as well. So let's go West Fraser. Let's go to 2-ply or 3. Yeah, let's try 2-ply 14. So 2-ply 14 works. So let's save this. Let's do LBM 1.2 2-14-inch LVL. So let's check this, and let's change this to a 14-inch LVL. The other thing you notice about lintels that I didn't really talk about, 2-ply, yeah, good catch. 2-ply 14, and then we can do our LBM 1.2. The other thing just to notice for lintels, and we can see it in section 2, but I always make our lintels at our top of plate, but I always make them -3 inches. And the reason why is we have 2 plates above the lintel. So if I open up this section here, you can see that the lintel sits a little bit below, but if I were to go here to annotate, and I can go to 2x6 nominal section. So essentially this is what we have going on. We have 2 plates above that lintel, and we always frame the lintels to the top so that if they ever wanted to change the window size, they wouldn't have to move the lintel. So we always frame our lintels to the top. Yeah. And then for simplicity's sake, since I'm here right now, let's copy this up to, let's paste this up to our first floor top of wall 4 so that we have our lintel up there. We'll still need to size it, but at least it's up there for us to size later. Same lintel is probably going to be fine for up there. So, and then you can see our big beam here. So that's sizing lintels. Let's do one more just for simplicity's sake. I'll see if I can find a really simple one. I think this one over here is going to be really simple. That one should be simple. This one, yeah, I mean this one should be really simple. So this one is kind of interesting because it's not really supporting any floor, but it is supporting roof. So the roof would be the 18'9". The floor I usually do in this case 2 feet. So it's not really supporting any floor because the floor joists are going the perpendicular. So let's go here. Let's go to calculator. And so the that window I believe is, actually let's just check. You can also just click on the window if you want to know the span. So this is a 36-inch window. So I'm going to make that, the beam span would be 3'2", so just 1 inch bigger on either side. Our floor span, so let's make this lintel supporting 1 floor and roof. Our roof span would be the 18'9". Our floor span would be the 2 feet. And then our overhang would be 4'11". And we can go back to material here. So I went over LVLs, but we can also do lumber built up. And we can just go to 2-ply, and we can go to 2-ply 8-inch. So this is a 2-ply 8-inch LVL. So LBM 1.3 2-2x8 inch build. So this lintel we'll probably use in a few spots because there's a couple small windows, but that's in general sizing structure. So we can change this to be 2-ply 2x8. I already have that there. Cool. So we can call this LBM LBM 1.3. So the last thing, just to show you, is if we go back into any of these beams, so let's go back to our LBM 214. So one thing I didn't do is I didn't place our posts on either side. So over here you'll have minimum bearing length. And so this tells you how many jack and king posts you need. So the way we do our jack and king posts, so I'm going to just grab this column that's right here, and I'm just going to bring this over beside our window here. And if you click on this, let me just make sure we have them loaded in here. So we have these multiple pieces here. So I'm just going to set this as a 2-ply for a second. And usually what we do is we do them as 1J, 1K. So that means the part on the right is supporting the beam. The part on the left goes continuous all the way up. So we call that, the one on the right a jack, the one on the left a king. But we model it as one piece because then we can tag it, and it tags really neatly. So if we tag this now, just use the tab button here. So if we tag it, it just tags really neatly, 1J, 1K. And usually contractors will know what that means. But let's go back to our beam for a second. So this minimum bearing is over 1.5 inches, which means we actually need 2J, 1K. Because it needs, basically, you can't have like a portion. So this is obviously in increments of this. So we'll end up having a 3-inch bearing. So let's change this to be a 3-ply 2J 1K. And then when we move this over, I move it over to the window, and then we move it over, generally it's 3/4 of an inch, but it doesn't need to be exactly. And then I don't always do this, but theoretically you can move this beam so it meets up with the J. Yeah. And then I'll just grab both of these here, and I can mirror this over to the other side. 2J, 1K, and then you can again stretch this over. And so we'd want to add those posts everywhere. Generally, the smaller lintels is just 1J, 1K. Anything bigger than probably 10 feet is probably 2J, 1K. And anything bigger than probably 16 could be 3J, 1K. But this software will tell us what the bearing is.
So, one? Can we make it 2?
That actually could be a potential. I would say with our stuff, it's usually always 1. If the only time we would get 2K would be based on the engineer. So if we had an engineer
so that's stable, right? Like 2J and 1K is the stable?
Yeah, it's the piece that's continuous, yeah. So that would just be based on the engineer. Typically it only specifies the jack posts, the bearing posts, not the actual king.
2J and 1K, I was thinking maybe could be not stable. Maybe
no, the wall studs are all connected, and then the sheathing on the outside provides stability. So that's in general how to start to size structure in a floor. So we want to do the first floor, and then we'd want to do the lintels on the second floor. This whole roof's going to be trusses. So we'd leave the whole roof for the truss company to do, but that's just how we do the floor system itself. So